So find the complex and real cube roots of negative 27 using de Moivre's theorem. De Moivre. So negative 27. So first, let's write that as a plus bi. So that's negative 27 plus 0i. So we know a is negative 27. We know b is 0. Then we need to find the length of it. So that would be just 27, because you do square root of 27 squared plus 0 squared. So the length is 27. This is z. The length of z is just 27. The sign doesn't matter, it's just how far it goes. So that's 27. We're going to write it in trig form, which means we also need to know what the angle is to get to negative 27, as if we were graphing a complex number. So if you were to graph negative 27, you would go to the left 27 and not up or down at all, because you go up or down the imaginary part. So we end up over here on the negative side of the x-axis, which just from that, you know that our angle, you can find theta that way. That means theta equals pi, because that's where we get, that's what the angle is to reach the negative x-axis. If you didn't want to do it that way, you could do tangent theta equals b over a, so that would be 0 over negative 27. Arctan of 0 is either 0 or pi, but then you have to think about the quadrant anyway, so that's how we get pi. So this would be cosine pi plus I sine pi. Now, when you're using de Moivre's theorem, we're doing cube roots, which means n equals 3. So we'd start by doing the cube root of 27. And then we get cosine pi plus 2 pi k over n, and n is 3. Plus I sine the exact same angle. Pi plus 2 pi k over 3. And then we have to do different values of k, starting with 0. So let's start with 0, and then we'll do 1 and 2. So starting with 0, you would get pi plus 0 over 3, and the cube root of 27 is just 3. So cosine pi plus 0 over 3 plus I sine pi plus 0 over 3. These will always be the same angle. So cosine pi over 3 is 1/2. And that's I times sine of pi over 3 is square root of 3 over 2. Multiply that out, and you get 3 over 2 and 3 square root of 3 over 2i. So there's one of them. To get the others, now we're going to do k equals 1. So it's still 3 cosine pi plus 2 pi, that's times 1, so that's 3 pi over 3, which is just pi. Cosine of pi is -1. Sine of pi is 0. So that's 3 times -1, which is just -3. So there's another root. And then we're going to do k equals 2. This is the last one we need to do, because you stop once you've done 3 things, because it was cube root. So that's 3 cosine pi plus 2 pi k. K is 2, so that's 4 pi plus pi is 5 pi over 3 plus I sine 5 pi over 3. So 5 pi over 3, cosine is going to be positive 1/2. Sine will be negative because we're down in quadrant 4. And that's square root of 3 over 2. So when you multiply that out, that's 3 over 2 minus 3 square root of 3 over 2i. And there's our 3 roots.